welcome back to my channel. So today we're going to tackle once again, University Physics with Modern Physics, Volume 1, 14th edition book. So we're still at this book and we're currently at chapter 15 entitled Mechanical Waves. So again, like the basics, I'm going to tackle 3 problem sets and we're going to solve them step by step in this video. So I hope that you guys would learn a lot from this video and about mechanical waves. So let's proceed to the first problem. Problem number 1. Sound having frequencies above the range of human hearing, so it's about 20,000 Hertz, is called ultrasound. Waves above this frequency can be used to penetrate the body and to produce images by reflecting from surfaces. In a typical ultrasound scan, the waves travel through body tissue with a speed of 1,500 meters per second. For a good detailed image, the wavelength should be no more than 1.0 millimeters. What frequency sound is required for a good scan? So it's about mechanical waves and we're going to solve for the problem is asking for the frequency sound that is required for a good scan. And so we're given in the problem the velocity and the wavelength, which is the velocity would be 1,500 meters per second. So that's the velocity of the waves of the ultrasound scan. And for the wavelength, it would be a 1.0 millimeters. So the formula that we would use would be, we know that velocity would be is equals to frequency multiplied by the wavelength. So we have to isolate the frequency in that formula so we can solve for it, because we have the velocity and the lambda. So using algebra, we would get frequency is equals to velocity divided by the wavelength is equals to the velocity of 1,500 meters per second, and the wavelength, we have to convert that from millimeters to meters, so you just move the millimeters in 3 decimal places to the left, or we just divide that by 1,000. We would get 0.001 meters, and calculating that, we would get 1.5 times 10 raised to 6 Hertz. So that is the frequency sound that is required for a good scan. So that's that for the first problem. Let's proceed to problem number 2. With what tension must a rope be with what tension must a rope with length 0.270 meters and mass 0.145 kilograms be stretched for transverse waves of frequency 45 Hertz to have a wavelength of 0.770 meters. So let's list down the given first. So we have the length of the rope, which is 0.270 meters, the mass of the rope 0.145 kilograms, the frequency of the transverse waves, which is 45 Hertz, and the wavelength or lambda, which is 0.770 meters. So the problem is asking for the tension or the force. So we know that velocity is equals to, in terms of waves, velocity is equals to the force divided by the square root of the force divided by the mu. And we also know that from the previous problem, we know that velocity is also equals to frequency multiplied by the wavelength. So we have to equate these two formulas together, and we would get frequency multiplied by the wavelength is equals to the square root of the force or the tension divided by mu. And we actually also know that mu is equals to mass divided by the length. And since we're given mass and the length in the problem, we can use those variables in solving for the mu. So plugging in the values, the frequency, which is 45 Hertz, multiplied by the wavelength, which is 0.770 meters, is equals to the square root of the tension or the force divided by the mass or divided by the mu, which is the mu is equals to the mass divided by the length. So the mass is 0.145 kilograms divided by the length, which is 0.270 meters. And isolating the force or the tension in this formula, we would get 644.78 newtons. So I just skipped to the algebra part. I actually just squared the formula on the right hand side to get rid of the square root, and in return you also have to square the formula on the left hand side, and isolating F, we would get 644.78 newtons. So for our last problem in this chapter, problem number 3, a piano wire with mass 2.90 kilograms and length 76.0 centimeters is stretched with a tension of 33 newtons. A wave frequency of 115 Hz and amplitude of 1.7 millimeters travels along the wire. Calculate the average power carried by the wave. So the problem is asking for the power carried by the wave. And so we have to firstly list down the given in the problem before we decide on what equation we would use. So mass is equals to 2.90 kilograms, which is given in the problem, and the length, the piano wire, is 76 centimeters, and we go ahead and convert that into meters and move the divided by 100, which would be 0.76 meters. And we're also given the tension or the force, which is 33 newtons. And for the wave frequency, we would state in the problem, which is 115 Hz. And for the amplitude, it would be 1.7 millimeters. We have to convert that into meters, so just divide it by 1000 and we would get 0.0017 meters. So we have to calculate the average power carried by the wave. We know that the formula for the average power is equals to 1/2 of the square root of the quantity of the mu times the force times the wave frequency, omega squared multiplied by a squared or amplitude squared. So there are actually two constants that we need to solve, or we need to modify a bit in this formula, which is the omega and the mu. And we know that the omega is equals to 2 pi multiplied by the frequency, and we're actually given the frequency is given in the problem, so we have to multiply that, but we'll proceed with that later. And for the mu, we know from the previous problem that we have solved, mu is equals to mass divided by the length. So we'll first solve the omega. So the omega would be equal to 2 pi multiplied by the frequency, and the frequency is 115 Hz, and calculating that, we would get 722.57 Hz. And for the mu, we know that it is mass divided by length. So the mass of the piano wire, which is given in the problem, is 2.90 kilograms divided by the length, which is 0.76 meters. So the value for mu would be 3.82 kilograms per meters. So now that we have those two variables, we can actually plug them into the formula, into the average power formula. So it would be 1/2 multiplied by the square root of the quantity of the mu, which is 3.82 kilograms per meters, multiplied by the force, which is 33 newtons, and multiplied by the quantity of the omega squared, which is 722.57 squared, multiplied by the amplitude, which is 0.0017 meters, and we have to square that as given in the formula. So the average power carried by the wave would be 8.47 watts. And that is it for this video. I hope that you all learned about mechanical waves for this chapter. Thank you so much for watching.